sometimes. Before we leave today, we'll put a link to Blackboard for you guys to submit this group exercise. But I put in here, under course materials at ME1800.com, a link to group assignment number 2. Okay, so we have some instructions for group assignment number 2. Oh, wait a minute. If you are currently enrolled in more than one group, and I believe this is just barely possible, because I created that set of groups, and I intended for you guys to join a group from the set, but some of you, I didn't even know this button existed, but some of you clicked the create group button and created your own group. And I believe if you have created your own group, it is also possible for you to be enrolled in one in the set. So you should be able to figure out if you're enrolled in 2 groups by going to the groups page. And it should show you 2 groups, yeah?
That was me. By mistake, I created one group. I'll try.
Yeah, there may be more than one person. Since we know it happened once, there may be 2.
I tried the group, I couldn't.
Anyway, if we determine that you're enrolled in 2 groups, or 3 groups, or 17 groups, we're going to send you an email, and we'll ask you which one you want to stay in. We'll help you take care of that, because we can add and remove people. If you're currently enrolled in a group that has less than 3 people, and there's like 2 people I know of that are in that condition, we're going to email you and we're going to combine those groups to make sure that we meet the minimum people requirements for you. Yes?
So when is this project due?
Wednesday, midnight next week. Group project will be due Wednesday, midnight next week. I had, first when I put the syllabus up, I was thinking it was going to be due the end of this week, because I wanted you to quickly do a group project after we form the groups. Otherwise, you're going to forget about groups, and you're going to forget who's in your group, because you wouldn't recognize each other. But I realized we don't have enough information to complete the group project in a timely manner, so that's why it'll be due next Wednesday. Okay, so for your group project assignment number 2, follow the example in the video below and create an Excel workbook. I think it needs to be Excel, but maybe not. No, it needs to be Excel. We told you it needs to be Excel. There we go, done. Requirement. Create an Excel workbook. Use the template provided to solve the types of problems listed below. So we got a video. There's an existing video there. I'm actually going to update that video with the one that we're creating right now later, maybe later today, definitely by tomorrow. But it has the same kind of information. We look at the video that's there. It's simply.
What? Did you get the email? No, my computer's not. Legal Larry said we can't.
I'm pretty sure I didn't tell it to have an add on, but I'm going to have to go check my default settings for uploading videos. The video that's here is from a different term, and so some of the information is in slightly different locations, but basically it steps you through, open up the Excel file, look at some reference material. We're going to make a video just like that today. Go that one. All right, we have an Excel file template. You should be able to click on this link and download the Excel file. Look at that. Which button should I click? Yeah, we automatically saved. We'll save it later. Yeah, we'll save it later. How's that work out?
That always works.
Well, for my case, you're going to click open.
They hit open. We can load up.
We'll click open. I recommend doing like a save as, and then make sure you control S as you're typing stuff. Anybody ever lost data that they needed right before they needed it? So I don't know if you guys know, I went to school here. Graduated in 95-ish. I think it was 95. I was on the 6-year plan, so it's hard to keep track. But NQP. Who's working on NQP right now? Who's got lots of backups of their data? Yeah, you might rethink that. 2 weeks before project presentation day, my NQP was a computer model of the knee, a 2D computer model of the knee showing the sliding motion and the springs and stuff to model forces on the anterior cruciate ligament during backwards falls while skiing. Fairly complex model in 1995 computer software. Yeah, so I had a printed copy of the paper. I had all the graphs and figures. This is back in the day when it was real tough to put the figures in Microsoft Word and crash every other second. So you did that right at the last minute before you printed it. Yeah, I got a virus. Wiped out my hard drive. Well, maybe you could recover from it, but I certainly didn't have the technology to recover from it that day. 2 weeks before the end. I had the paper, and I had printed versions of some of the graphs. I had to recreate my entire MPP in 2 weeks. So remember, you did that thing. Save as. All right. So we got our Excel file. It was kind of fun. I learned, well, I made a macro that saved in 3 locations after that every time I clicked Control S. So I learned how to do some macro programming in Excel. All right, so what we've got here is a sheet that says Q1, a sheet that says Q2. Notice Q1 has stuff in it, because that's what I want your stuff to look like. What is this Q2? 3, 4, 5, 6, so this goes out to 10. We go all tab back over here. Go down here. Number 2. So question 1, given. So given the side edge cutting angle and the feed rate in millimeters per revolution, calculate the uncut chip thickness. You guys know how to do that, right? We talked about it like 6 times yesterday in lecture. Calculate the uncut chip thickness. But what I want you to do is not just know how to do it, right? Because you could just type, so you could type that equation, right? We could go to our Excel spreadsheet. There's Excel. And I'll just create a new sheet since I already have number 1 answer. But I can go to my Excel spreadsheet and I can say, what were we given? See, I forgot already. This is tough. You know what I can do though? Alt tab. Right, we're back over here. I do Alt tab. I can keep doing this all day long if I wanted to. It's even easier if I go do that. And I say copy. Alt tab. Hey, now I know what the question is. That's cool. So now when I come back to this page, I'll know what the question is. And there must have been a slide or something that showed us the answer. I think there is. In fact, I provided for you in the resources reference materials. I love it all the first time. Amazing. We talked about profit rate in class. Where are we getting down here? Right, this is where we're talking about. Yeah, this one. This is where we're talking about uncut chip thickness. All right, so we're looking at our thing, and we got a little triangle here, and we can figure out y is the cosine of the angle if we want to. But we remember our equation, so what I can do here is I can say semitool. Now I have my reference for what the answer is. Save that. Go over to Excel. Paste it. And so now I have the question. I have the answer. All I got to do is type in the formulas. So, given. All right, so what am I given? Side edge cutting angle. And what else am I given? And I like this one also. That. So what's the side edge cutting angle that our tool might have? This one right here, it's printed on the little thing, has a side edge cutting angle of 4 degrees. And so remember that side edge cutting angle is how much the tool is tilted in this direction. Right, so our side edge cutting angle, here's our tool. The workpiece is rotating this way, right? The chip's forming on the right face of the tool and sliding this direction. We can change the side edge cutting angle by moving the tool this way or this way. All right. So I don't know, you can have 45 degrees. What kind of feed rates? Anybody notice what the feed rates were when you were running the lathe? or remember what you guys haven't done any late programming yet, right? That's after this week. Next week, I think we start late programming. So you haven't done any late programming yet. Anybody notice what the feed rates were when you were running the parts? We have to calculate them in the feed to speeds assignment, maybe? No? So, might feed at, I don't know, 0.008 inches per revolution. So 8,000ths of an inch per revolution. That's a reasonable feed rate. So it's a lot easier for me to do my equations if I've got numbers to play with, right? Does that make sense? You can see if you get divided by zeros and stuff going on. All right, so what's our equation again? Oh, so what are we looking for? Find uncut chip thickness. We're going to call that T1 lately. In millimeters? Inches, millimeters? Because I said this was this thing. Inches per rev. This is what, degrees? Keep track of our units while we do this. And so how many millimeters to the inch? So I'm going to have to calculate something in between, right? How do I convert inches to millimeters? So this equals 25.4 times this. Does that work? You guys all see that on the screen? Do we need to zoom in or anything? All right. So now I got millimeters per revolution. Look at that. All right. So we would like our feed rate, our uncut chip thickness, right? What's that equal? Okay. It equals P times cosine is that the right answer? So our feed rate is 2 millimeters per revolution, and it calculated that T1 is about a tenth, or so 0.2 millimeters per revolution, sorry. Calculated T1 was about a tenth of a millimeter. Is that the right answer? Michael, you've used Excel before.
No, well, I think you have to use radians.
In Excel, when you do cosine, sine, tangent, inverse tangent, arc, whatever, all those things, it wants radians, not degrees. So equals. So what's 45 degrees in radians? What's the conversion? Ah, even better. Radians. Look at that. Holy crap. It's like magic. And so I got my equation here. Well, there.
You might want to put radian.
Yeah, we should label it, right? I could just put rad, because it's a pretty rad number. Right? Oh, look, we were expecting like 0.7 radians. So now, because it was 45 degrees, and that was close to the same thing, we got almost the same answer down here. So you want to make sure that you're using radians. All right, so along comes a quiz question. And it said, side is cutting angle 0. The feed should equal the chip thickness, right? So we can test it too. We've got some confidence that maybe we've got the right equation. Okay. All right, so when you do this group project, I want you to make, and I already gave you this one, and I gave it to you twice now. Because that should be the same answer, right? Except here, I didn't do the conversion, did I? So this one is uncut chip thickness in inches, right? So in the example, I did the problem on. All right, does that make sense? So don't be the group that on this page only has numbers. Because last term, like a third of the class, on some of the pages, only had numbers. If you can't go to this, where are we? You can't go over here and find the picture that has the equation you need to use to do that conversion. You can draw your own picture. My picture. Good. Oh, wait, it's my picture. You take a selfie of it and put it in there, right? I want to have a diagram. You could use the fancy drawing tools in Excel. I don't care what it is. You can actually take it out of social media. We'll put it on the side. My picture. Okay, so does that make sense? You guys want to do that? You want to do some more example problems? You want to test a few of these? Sure. Yes, we got some time. What else we got? All right, so let's pick another one. We'll cut this out of the video we can post it. Because now you guys have enough information to do the group assignment, right? Assuming, well, you can figure out the answers to all the questions. But let's look at one down here. Let's see. Question 7. So this is right down to this copy and paste from a Word document. I'll clean up all that again. Shaded. Question 7. Given original diameter. Wait, what are we going to do? Take a picture. So when you do your answers, put them in the right little cube thing down here. So that when we're grading them, it's fast and easy for us to grade. Got it? If it's easy for me to grade and fast, you get a higher grade even if you've made a mistake. If it's a pain to click through because you didn't follow the format, you get a lower grade because in the assignment I told you to follow the format. But over here, I'm just going to make a new sheet. We'll play with it over here. Here we go. Here's my new sheet. Paste. All right. Okay. We pasted it now. All right. So original diameter. OD. Final diameter. FD. Spindle speed. RPM. Look at that. All right. So what are some numbers for original diameter and final diameter you might see in a lathe that we would run? Anybody see those parts? You pick up parts of the lathe? How big do they start out at? All right, we'll go with 2 inches. How about a final diameter on your lathe? What kind of things are you looking at? We'll make one pass with the zoom here. 1.8 inches. All right. 1.8 inches. What kind of speeds? You guys watch the spindle speed monitor on the lathe when it's running? What kind of speeds you been spinning those lathes? We don't spin the lathe at 6,000 on purpose usually. Mini mills go 6,000 all the time. The lathes, we're worried about all that mass of the spinning chuck. It does go 6,000. Especially lathe number 3. At 6,000 RPM, it vibrates enough that you can just push it across the floor without having to pick it up. A little bit unbalanced. So, anybody seen? Yeah, 1,600. 1,600. Let's go with 2,000. It's a nice round number. We usually set the clamp speed. So the clamp speed is the speed not to exceed in the lathe, no matter what the program tells it to do. We usually set that around 2,000. I think that's 3,500. All right. So I got original diameter, final diameter, spindle speed, and what do I want? So this is given, right? We should label that as given. I think I said up here calculate, but that's a lot of letters. And we're looking for surface speed, right? And so this is rev per minute, right? And this is feet per minute.
Referring to RPM with the minute.
Well, I could call it spindle speed and surface speed, but RPM is, it's an abbreviation, right?
Yeah, and
It's not an acronym, it's an abbreviation because we don't say ooh.
and it's also kind of a thing.
Yeah, but it means revolutions over minutes, which is why I write it twice. But if I say in, I see what you're saying. It is kind of redundant. But when you write out RPM, I don't see that as a unit. I see that as a common phrasing. That's sort of the thing that we say. I suppose maybe it is a unit on its own, and it equals rev over minute. It's easier to do math when you've got the little line sign there. It's easier for me, at least, to keep track of it in my head. All right, so we're looking for surface feet per minute. So we could go back at our list of equations. I'm pretty sure this one's in there. But anybody remember how to figure this out? What if we didn't have a list of equations? Let's figure it out ourselves. Somebody tell me how to start. Let's start with a picture. Insert a drawing tool, right? You know a drawing tool? There it is. I'll go around. All right, I started. What do we want to do? Oh, this picture over here. So what do I want to do if I want to figure out surface speed? I know the outside diameter, finished, first and finished. What am I going to do?
Basically, the same thing that you would do in tool that you treat the average, which means the final diameter, and the original diameter.
Yeah, so if I got, so that's sort of like this, right? That part looks like this. So here's my OD. Here's my FD. All right, so Zeb wants to use the average of those two as the diameter that we care about, right? We need a diameter. So we can say D equals OD plus FD divided by 2. Right, and so for our example, that's going to equal 1.9 in our example, right? All right, so we got a diameter. Anybody disagree? You guys are willing to go with this? Okay. I think the average is a good number to use. You could use worst case scenario, the surface speed is going to be faster when? At the original diameter or the final diameter? At the final diameter, right? As diameter goes to 0, surface speed goes up. Right?
No,
No. The original diameter, surface speed is going to be faster for the same RPM, right? If diameter goes to 0 and we would like to maintain a constant surface speed, then spindle speed has to go up. And so there is a command on the lathe to tell it, this is the surface speed I want you to go. Maintain a constant surface speed, which is why we have that clamp speed command of 2000. Otherwise, when it got to the center, when it was facing off the part, it would have to go infinite RPM. Which would be really cool if we could get a lathe that could spin at infinite RPM and not vibrate across the floor. But it would be unsafe, I would guess. Right, there's that whole time and space thing going on too that we want to watch out for. All right, so we got a diameter. The average diameter will work. I guarantee the answers to the quiz questions will accept the average diameter as a possible solution. They will accept the original diameter as a possible solution, and they will accept the final diameter as a possible solution. And I get to set a tolerance band. And so as long as you're within that band, you'll get the right answer if we haven't screwed up the quiz. All right, so I know my diameter. How do I calculate surface speed from diameter? Anybody remember?
It's RPM times 12 over I times 100.
That's what you mean? Is that the correct formula?
No, and that's what you want to convert surface speed to RPM.
See, there's these formulas, and we can memorize them, right? But I can never remember which one it is. But what I do know is that I have inches in diameter, and I have 1.9 times pi inches per revolution now, which is why I like to have my units over here. So I can calculate here. Let's move this line down a little bit. We have to calculate some stuff in the middle. What am I calculating here? Circumference. Circumference, right? That's how you spell it?
No, that becomes around.
I'm not going to take points off if you spell words wrong on my notes. Equals. You know, it's amazing. My 9th grade report card from, you know how they break little notes sometimes, the teachers do? My 9th grade report card, the history teacher, he wrote, Toby is very exciting. It's a joy to have in class. Possibly the worst speller I've ever met. Because I kind of took pride in that because I wanted to be in here anyway. But my 7-year-old daughter is now, she's 2nd grade. She's been doing spelling tests since kindergarten. Has not yet made a single mistake on a spelling test. Including, like, the day they bring the spelling words home, we do a pop quiz. She has never once spelled a word wrong in my experience. That is not from me. I did that from my side of the family. The gene skipped a generation. All right, so circumference equals pi times average. Is that right? Inches. Right? We don't need inches though, do we? We need feet. Equals divided by 12 feet. And that's feet per revolution, right? That's feet per inches per revolution. All right, so we got our circumference. And so now if I multiply this number by what? What do I have to do now to get from, I want to go, so I got inches per revolution, then I can make that feet per revolution. So I got feet per rev. What do I want? I want and so feet per rev times rev per min. I like this. Equals feet per minute, right? This is your picture for your slide. I mean, alternately, you could have gone. Could have gone over here. Is it this one? RPM. So alternately, you could have picked this slide because we made this for you, just in case you forgot. We also had a slide that was sort of like this in the lab exercise where we did feet and speeds, right? You could pick that as your reference. So you can draw your reference picture. You can pick it from one of the presentations that we've had here. You can pick it. So I tried to have this document contain a slide for each equation that we touch on, each circumstance that we touch on through the class, including stuff we haven't done yet. We haven't finished the class yet, have we? No. Okay. So that stuff's all in there. This equations and ME1800 thing. It's sort of a living document. We update that as we go. Sometimes we find that there was a typo on one of the slides and we said something wrong. So don't take this as gospel. There could be problems. As we find problems, if you think something's wrong on it, put it in the discussion forum or email me or tell the PLAs. We can fix it if you're right. So we'll keep updating that as we go. I didn't give anybody any candy today, did I? I was too. Well, I was too excited about talking about Excel. So if when you leave today, you feel like you deserve a piece of candy, you should take one. If there's anything anybody else wants to talk about, we'll give a little bit extra time today. We could do another example problem if we want to. I think you got the idea of it. You guys want to do an example problem where we look something up from the machinery's handbook? Because there's questions where you need to look stuff up from the machinery's handbook in this exercise. All right, let's go to power. Measured power equals to the spindle. Yeah, here we go. Question number 9. Sounds like a Beatles song. I get one chuckle. Number 9. All right, so we've got power to the spindle given to us. Right, so what's power to the spindle? It's like current times voltage. Right, so we got power to the spindle by measuring current times voltage. Okay, so that's at the motor. What we want, really calculate the friction coefficient? This is a mean question. What do we have to do to calculate the friction coefficient? Yeah, unfortunately, this is one you can't look up. Exactly. Exactly. We need to calculate the friction coefficient. We need to come down here to all these transformation things, the geometry ones, cutting across force, shear normal force. All right. So friction forces. So F over N equals friction coefficient. So in order to get the friction coefficient, somehow we're going to have to know what F over N is. So let's go ahead and start there. I remember this question now. This is a people question. You have to know a lot of stuff to figure it out. And by evil, I mean more like a really scary question. Right? So we're going to have to know this. Well, how can we find that out? Well, if we know the, we can figure out F if we know the thrust force and the cutting force and the rake angle. Any of those things given? We measured the thrust force. I like that. That's FT. We know the spindle type, we know the surface speed, and we know the rake angle. All right, so I'll have back here, this equation is going to help us, right? This one? All right, so I'm going to copy this one too then. Because right now I'm just trying to figure out how could I figure out the answer. So with the given information here, measure thrust force and rake angle, measure thrust force and rake angle, what am I missing if I want to figure out what F and N are? Nick, I'm missing the cutting force, right? That FC. So how can I get the FC? I can get it from those equations from the machinery's handbook at page 1054 or so. Or I can come back over here to my equation thing and I can scroll down to where we're talking about that stuff. Look at that. Moving somewhere. It's above this. There it was. It's above this. Right, so we had this equation. We talked about, we were talking about power of chip formation. So the power we measured, right? And I got my PC is my power to cutting tool, so I need the specific power for cutting. And how do I get that? I look it up in a table down here. And did they tell us the material? Oh, yeah, so this question is broken. Let's take this question. Look at this. I have the technology to fix this question. First, we're going to supersede the page here. Hey! So I'm going to go to that page now, right? Go back to that page. Magic. Page. What was it? 9? Workpiece material is more clear. Yeah, workpiece material. We'll figure this one out later. Fix. Question no longer broken.
Well, you didn't say what the material was out there. You just said the workpiece material.
Right. You're given the workpiece material. Right?
But don't you need a specific workpiece material to actually solve it?
You will, and when you get the quiz question that's associated with this, we'll tell you what the workpiece material is. So you'll have to have a place where you can input that KP value.
Yes, sir.
If you want to be real sophisticated, you can have a lookup table. But I don't think I'd bother.
Yes,
I think I would just input it. You might do this. I don't know what that is, but no. So what you might do over here is copy this page. Right, we can do that. Right, so we can put this page over here. This one has a lot of stuff. All right, so we know the KP, so we know the spindle type. In our spindle type is on this slide, right? If you go to 1054 in the machinery's handbook, you'll find that there's a conversion from power at the cut. This is power at the cut. We have power at the spindle. There's another factor, it's called E. You're going to multiply that, that's the spindle type. You can look that up on the machinery's handbook. We got spindle type, negative thrust force, surface speed, rate angle. From this, we can figure out the cutting force, FC. We know the FC and the FT and the rate angle, we can figure out the friction coefficient. So you're gonna have to look at more than one source to solve questions like number 9. I'm happy. Are you guys happy? So if you haven't figured this out yet, if you missed one of the lectures, and I know I'm talking to the people that are not here now, you can go to. You probably shouldn't log in with my supervisor. You can go down here to course materials. Come on. ME1800 C16 echo capture. You can wait for the internet. I'll say okay, it's gonna, for some reason it makes us refresh when we use certain browsers. And look at this, you can watch the live broadcast. I've never, this is like a fractal now. Mike, watch out for space on the video.
So, what we have to do this Friday,
There's a CAM assignment due Friday and there's a survey due Friday. That's it, because I decided to make the quiz that goes along with these questions due after I have you do this group assignment. You're supposed to be able to watch it live. I want to see it live. Oh, there we go. Totally redundant. Survey. I want to see it live. The survey for this week. Oh, there we go. Totally redundant now. Oh no. The audio. I want to see it live. Oh, there we go. Totally redundant now. The audio. I want to see it live.